Lesson 4-5 on more triangle congruency conjectures. Now, so far we've discussed three different ways of proving that triangles are congruent. The first conjecture was the side-side-side, or SSS conjecture, which said that if two triangles shared three pairs of congruent sides, that was enough information to prove that the triangles were congruent. In addition, there was the SAS, or side-angle-side congruency conjecture, which said with those two triangles, if you had two pairs of sides and an included angle that were shown to be congruent, that also was enough information to prove that the triangles were congruent. And finally, ASA, which said that if two triangles shared two congruent angles and an included side which was also congruent, then that was also enough information to prove that the triangles were congruent. But of course, there were a few configurations that we haven't discussed yet. For example, angle-angle side. Two sides and a non-included angle. Notice specifically here the congruent side is not located between the two angles as ASA is normally configured, but outside the two angles. Well, we can use some reasoning to figure out whether or not this is true. First of all, what does the third angle conjecture say? The third angle conjecture said that if you had two triangles where you had two pairs of angles that were both congruent to each other, then you can conclude that the third pair of angles were also congruent to each other. In addition, now take a look at why you can say those triangles are congruent. Once we've added the third congruent angle, now notice that there's specifically an ASA configuration that allows us to prove that the triangles are congruent. This leads us to the AAS congruency conjecture that says that if any two angles in a non-included side of a triangle are congruent to two angles in the non-included side of the second triangle, then the triangles are congruent. Now, how about the angle side-side configuration? Two sides in a non-included angle. Notice specifically here the angle is located outside the two sides, not between them as SAS is normally configured. Well, we actually did this problem in our homework assignment back in chapter 3. And the way that problem worked was this. We began with two segments in an angle, and we were asked to first construct the segment and then construct the angle on top of the segment. Then, taking our compass and measuring the length BC, we could actually pivot that length on point B and make a sweep across the angle. And when we swept that segment across the angle, we found 2 points of intersection. Now, these 2 points of intersection actually led us to create two different triangles. Remember, in all the other construction exercises, we actually made one unique triangle from the parts given, but here we can actually make two different unique triangles. Because of that, ASS is not a valid configuration to prove if triangles are congruent. Honestly, don't ever even try to figure out whether or not you can even try and create triangle congruency from angle side-side. Remember that triangles are not congruent just because they share the same size angle side-side. And finally, how about angle, angle, angle? If we have two triangles that have three congruent angles. Well, this is clearly not enough information, and here's the reasoning behind it. If we were only given three congruent angles, angles alone don't depend on the length of a side. One triangle could be really small, another really big, and both still have the same angle measurements. For example, if we had triangle ABC here and triangle DEF, these two triangles could easily share the same angles. But because there's no individual side to lock us into a specific length, we could have one triangle be twice as large or 3 times as large as the other and yet still have congruent angles. So this alone is not enough information to prove that the triangles are congruent. Thus concludes today's lesson.